All right, so today we're going to get into net ionic equations. Net ionic equations are a different way of representing chemical reactions, like a balanced equation. But what it actually does, when you think of something that's in the net, you're boiling it down to just the actual chemistry that's going on. Just because something's in an equation doesn't mean that it's actually part of the reaction necessarily. Sometimes it's just a spectator. Sometimes it's just there as an ion in the solution, but not actually performing. There's not electrons being gained or lost by that particular ion. So sometimes we can get rid of it. So when we write net ionic equations, we break things down, or we separate things based on we can separate three different things. So we can separate strong acids, strong bases, and soluble salts. Soluble salts. So why can we separate those three things? It's because when we put those in water, they're going to dissociate completely. So when I put, for instance, NaCl in water, it's going to dissociate into Na plus and Cl minus. So we're not going to have any of this floating around in our water, or very little of it. We're going to have sodium ions and chloride ions floating around in our water. Same thing with the strong acids and strong bases. If we have a HCl, which is hydrochloric acid, that's a strong acid, it's going to completely dissociate into H plus and Cl minus. Okay? So when we talk about, we need to know these three things. So strong acids, there's 6 strong acids. The strong acids are HCl, HBr, HI, HNO3, H2SO4, HClO4. Okay? So hydrochloric, hydrobromic, hydroiodic, nitric acid, sulfuric acid, and perchloric acid. Then the bases, the strong bases, are the group 1 and 2 hydroxides, with the exception of beryllium and magnesium. So if hydroxide is bonded to any of the group 1 or 2 elements besides beryllium and magnesium, then it's a strong base. And then for the soluble salts, you got to remember your solubility rules. So you can look those up, or if you have them memorized, then you can use that. Okay. So how do you go about doing this? So if we're given, a lot of times you're just given the reactants. So if we have, let's say we have potassium iodide solution plus lead nitrate solution. I need to figure out what the products are. I need to predict the products of this reaction. Well, just by looking at the reactants, you should be aware that this is a double replacement reaction, because I have 2 compounds, 2 aqueous solutions. And so the outsides are going to go together, and then the insides are going to go together. So K is going to be with NO3, KNO3. That is aqueous. That is a soluble salt. Potassium nitrate, all group 1 compounds, and all nitrates are soluble. And then the other thing we have is lead 2 iodide, which is going to be a solid that is insoluble. So that's going to be our solid that forms in this reaction. It's going to be a precipitate. So now, so this is the normal equation. So if I want to write the full ionic equation, I break apart the things that I can break apart. So this is a soluble salt, so I'm going to break that apart. K plus I minus. This is also a soluble salt, so Pb plus 2 plus NO3 minus yields K plus NO3 minus. And since this is solid, I cannot break it apart. So I can't break apart solids or liquids. The only thing I can break apart or dissociate are the strong acids, strong bases, soluble salts, if they're in aqueous solutions. So this is the equation. This would be the total ionic. So this is all of the ions. Then when we get to the net ionic, what we do is we cross off what occurs on both sides of the arrow. Because what happens is the things that occur on both sides of the arrows were simply spectators. And so we can get rid of them. So I can get rid of there's K pluses, so I'm going to get rid of those. And there's also nitrates, so I'm going to get rid of those. So what's left is I minus plus Pb plus 2 yields Pb I2 solid. Then you still have to balance it. Since I have two I's over here, I would need a 2 there to balance it out. Okay. All right, let's try another one. Let's try one where we have, let's say we have HCl plus NaOH. So this is an acid-base reaction, and it's also a double replacement reaction. So the insides go together, so I'm going to have NaCl, which is a salt, a soluble salt, plus HOH, also known as water, which is a liquid. Okay. So this is my full equation. If I want to do the total ionic, so HCl, that's a strong acid. So I break it apart, dissociate it. NaOH, that is a group 1 hydroxide, which is a strong base. So that does get broken apart as well. NaCl, it's a soluble salt. And then water is a liquid. So we do not break liquids apart. So there's my total ionic equation. And what can I get rid of? I can get rid of the NAs. I can also get rid of the CLs. And then I'm left with H plus, OH minus, yields H2O. So this would be my net ionic equation. And for any strong acid, strong base reaction, this will pretty much always be your net ionic equation. You're forming water. Okay. All right. Let me know if you have any questions. I hope this helps.